Okay, hi everybody. This is the first lab in Module 5. We are starting to create some data, and this is going to walk you through the process of georeferencing. This picture is a picture of a blimp that Dr. Wheaton flies when he's collecting high-resolution survey data of stream reaches that are open enough to be able to fly a blimp. But basically there's a little contraption that hangs down off the blimp that allows us to attach a digital camera that can shoot images at 5-second intervals. It's got a little GPS unit on it, but it's your standard point-and-click camera. The blimp is filled with helium. Students fly it with just this big kite-flying contraption, and it's pretty fun. We fly it in the spring over the quad at the Logan campus, and the students take those images and georeference them to a known coordinate system. And you're going to be doing the same thing, just without the blimp. All right, so we give you an image from 1953. This is an image with no known coordinate system, but we also give you an image from 2002 that does have an assigned spatial reference. We do know that north is up, it has a coordinate system, and a set scale. But we're going to use this 2002 image to lock onto different locations on the map or on the image and basically rotate, spin, and resize the 1953 image and then rectify it to a known coordinate system. So I just want to give you a couple hints to get started. Notice that Sulphur Creek runs right through town on both these images. That can kind of help orient you a little bit. I would not recommend using Sulphur Creek as control points when doing the georeferencing because over 50 years the channel is certainly migrating. Notice that there is a nice big wide road that runs right through town that Y's right at the river. That's visible on both images here. That road comes in here and then splits right at the creek. So what I would do is focus in on this area of the Y. You're going to want to get these two images sitting on top of each other in ArcMap, and then you'll be toggling the visibility of the 1953 layer on and off. And what you want to do is zoom way in until this image almost starts to pixelate. And look for buildings, intersections, street corners, any feature that you can really easily identify in both images, and use that as your first control point. The first control point is going to act as a pivot point. Your second point is really critical. That's the one that will allow you to rotate and rescale this 1953 image relative to 2002. So after placing the first point, you really aren't going to see any major changes except for this image is going to shift a little bit. The second point that you place will allow this image to be rotated correctly and rescaled so that they sit on top of each other much easier. Then when you toggle the visibility of 1953 on and off, you won't be kind of zooming back and forth and panning across the image to find the same location on this map. It should be sitting right under it. So you need to add 4, 5, 6 different points. You want to make sure you spread them out in the image as much as you can. When you get away from downtown, things get a little iffy, but do your best to spread the points out. That's how you get the best fit. When you start creating sets of control points, I don't know if you can see the little red and green crosshairs here. Those are the locations of the points from each of the two maps and how they sit on top of each other. The links are built in a link table, and you're going to want to manage this pretty closely. Once you get 5 or 6 points placed, open up your link table and take a look. The residual column shows you the amount of error between the two images. And even though your first 2 points probably make the most sense to you, they'll probably end up having the highest residual error. So once you get 5 or 6 points in here, it's going to calculate a total RMS. This is the root mean square error. You want this to be as low as possible. Also pay attention to the transformation. You need to report this on your final map. But once you get 5 or 6 points in here, you're going to want to delete some of the biggest offenders. So all you do is basically highlight the line and then use this X to delete these links. What I would probably do is get rid of both of these, and then with this better fit, go back and find those initial locations and see if you can create a better fit and a lower RMS error. Using those first locations, you might need to get rid of some of these outliers. But again, remember to spread out your points as much as possible. It's a really straightforward process. Getting started is the hardest part and getting yourself oriented. But once you get going, I think it gets a little addictive. So you're basically going to be creating a formal map exported to PDF showing us the correctness of your georeferencing. So you want to focus your cartography on proving to us that you've gotten this 1953 image into the same coordinate system as the 2002 image. So this student has chosen to put a coordinate grid. This is really useful. We can tell from these units that it's the same coordinate system. You could, build in some metadata about that as well. You want to make sure that your alignment is spot on. Those little details, when you're doing a side-by-side comparison, you want to make sure that the little details are really crisp. It can get distracting if these two grids are off a little bit. One scale bar is sufficient. When you're using a grid like this of the coordinate system, this is the same thing as a scale bar because these are units in meters. But, for your more general audience, a scale bar might be helpful. I would recommend left aligning it with one of the two maps, but that's kind of a judgment call. Remember that these representative fraction scales, these are false on digital maps. If this person could control the scale at which, or the size at which this map was always being displayed, this would be correct. But that's kind of nitty-gritty. Good title, clean layout. This is another example of a map that you might create. But here the scale bar is left aligned with one of the maps. Doesn't need to be repeated for both. I think this map does a really nice job of displaying the differences. I like this simplified grid. It's not quite as cluttered as the other map. Yeah, so that's it.